Alrighty, everybody, I just got the okay to start our planetarium show. So I'm going to put away our space trivia questions and that important message up on the screen because now we're going to be heading into the unknown. Ooh. And good afternoon, everybody. Welcome to the Morrison Planetarium. Really quickly, I just want to introduce myself. My name is Christian. I want to be your planetarium presenter. And just a heads up, I'm not just a voice coming out of the walls. I'm actually a person, and I'm standing right behind you. Hey, how's it going, everybody? Don't hurt your necks. Look forward into the dome before you. That's where the whole show is going to be. Everything that in purple, that's going to be our enormous screen before us. And to tell you folks, the show that we're going to be watching right now is by far my favorite to do here in the Morrison Planetarium because this show is completely live. What we're doing is something called Tour of the Universe. So you're going to hear my voice for the next 30 minutes. And we're going to be starting off pretty close to Earth and we're going to be zooming all the way out to the very edge of the observable universe. Hopefully, by the end of the show, you won't have an existential crisis of where we are in space. But just a heads up, we are very small in the grand scheme of things. So I just want to forewarn you. But before we get started, folks, I do got to go over some quick house rules just so that we're all on the same page. We have a great experience in the planetarium. There's a few of us in here. First off, there's no food or drinks allowed inside. If you manage to bring any snacks, make sure those are put away till the end of the show. We want to keep the theater clean for all the guests coming in the future. Also, if you happen to have any cell phones, smartwatches, tablets, anything that produces bright white light, now is the perfect time to turn them off, deactivate them, put them away for the next 30 minutes, as these could be very distracting in our planetarium because this room is going to get quite dark, and a really bright white light takes away from the planetarium experience. And also, folks, if you need to exit the planetarium at any point during the show, you're more than welcome to do so. All we ask is that you exit at the very top of the planetarium. That's where you'll find the exits before, during, and after the show. Although if you're a person that has trouble climbing the stairs, don't worry. Just remain seated. Once the show's over, we'll have a staff member escort you to a lower exit. So just hang out a little bit after the show, and we'll help you out. And last but not least, folks, this show is very immersive thanks to our 70-foot dome above us. If at any point during the show you start to feel overwhelmed, motion sensitive, there's a really quick trick for you to help ground yourself. All you got to do is close your eyes, take a few big deep breaths, and your brain will remember that you're sitting in a planetarium in San Francisco and not flying across the universe, at least not more than the usual. Hee hee hee. But with that being said, it looks like we're ready to go. So I invite y'all to sit back, relax, and enjoy Tour of the Universe. Alrighty, everybody. As I mentioned, we're going to be starting off pretty close to Earth, but not exactly right on our planet Earth, just a little bit above it, here at this really fancy contraption known as the International Space Station, or the ISS for short. And a lot of people tend to ask me, hey, Christian, what's the International Space Station? I hear about it all the time in the news and articles, but I don't really know what it is. Could you explain it? Of course, folks. Well, the International Space Station is a research facility, laboratory that orbits around our planet Earth. And how it came to be, well, a bunch of countries, a bunch of nations all across planet Earth want to figure out what happens to things in space. For example, what happens when you try to grow plants in space? Do the plants grow the same? Does that grow differently with less gravity? What happens when you try to spark a match in space? Does the flame act the same? And one of my favorite experiments that they've conducted on the International Space Station is where they had two identical twins. One twin lived on Earth for a year, the other one lived on the International Space Station for a year. After that year, they compared and contrasted. Turns out when you live in space for a long period of time, you tend to age a little bit slower. But not only that, you also lose a lot of body mass index. You lose a lot of muscle because you don't have gravity constantly working on your muscles all the time. So if you plan to live in space for a long time, remember to exercise daily. And also, folks, when we're looking at the International Space Station here, it looks enormous on our planetarium dome, but it's not that big in actuality. It's only about the size of an American football field. So, um, not too big. If you've never been to an American football game, don't worry. You can also use the entire California Academy of Sciences, the museum that we're sitting in right now. That's how big it is. And what's also really amazing, folks, is that the International Space Station is going really, really fast. It's going a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes, where it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. And right now, it also looks like we're really far above the planet Earth, but that we're not too far away either. We're only about 225 miles above the surface of planet Earth. So 225 miles, that's not that far in terms of California norms. That's like going from San Francisco to Santa Barbara, a nice little road trip to get away with the family for the weekend. And to tell you the truth, folks, traveling out here in space is very, very expensive. You got to get yourself a rocket ship or build yourself a rocket ship, and then you have to account for all the rocket fuel. And you're going to need a lot of rocket fuel. And then once you get your hands on all that rocket fuel, you have to account for all the food, water, all the air you're going to be breathing while you're up here in space. So the bill gets quite costly. So this is as far as we put humans into space nowadays. So only 225 miles above the surface of our world. But folks, the International Space Station is just the first stop on our tour of the universe. So let's slowly leave it behind. And now we're going to start to see it slowly fade away compared to our planet Earth. Looks like we're hovering just above India. So we're going to see it slowly disappear compared to the city lights down below. And before we lose track of the International Space Station, I want to add a nice orbital path so we can keep track of it as it slowly disappears. There we go. And now, folks, we are zoomed so far back now that we can now look down at our planet Earth. And to tell you, folks, the space program that I'm using here in the Planetarium Dome is something that you can download and use yourself if you like and fly through space. The space program that I'm using is something called OpenSpace. So if you go to your favorite search engine, type in OpenSpace Project, then you'll find the website where you can download it. And it's a whole lot of fun. But just a heads up, folks, OpenSpace is not completely finished. It's in its beta phase, which means we may come across a few bugs and glitches. If we do, I'll point them out for you, and hopefully we can look past them. And also, just to let you know, OpenSpace uses a whole lot of processing power. So if you have an older computer, I wouldn't recommend downloading it. It may overwhelm that computer. But if you've got something newer or a gaming computer, give it a try. It's a whole lot of fun. But if you're a person like me that doesn't want to download anything, we also have another great alternative called NASA's Eyes. So just kind of like the human eyeball, type in your favorite go to your favorite search engine, type in NASA's Eyes, and then you don't have to download anything. You can fly through space just like how I am. So two amazing space programs that we use, OpenSpace and NASA's Eyes. But let's leave the Earth behind because now we're going to be making our way over to our nearest natural neighbor to us in space, folks, the Moon. And folks, to tell you, we humans have been to the moon before, but that was quite a while ago. That was between 1969 and 1972, thanks to NASA's 6 Apollo space missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon, conduct science, and of course, they had some fun up here as well. They got to play some golf. And luckily for us, we're inside a planetarium, so I have some special abilities here. I'm going to turn off the nighttime on the moon. There we go. Hey, moon, good to see you. It looks much more familiar. And again, folks, last time we sent humans to the moon was 1972, so a little more than 50 years ago or so. But don't worry, NASA has a new space mission in the works that's going to be sending humans to the moon in the next few years. This new space mission is called Artemis. And pretty much the whole purpose of Artemis, NASA wants to send humans to Mars, but before we send humans deep into our solar system, we need to figure out exactly how we're going to live out here in space. So the moon is the perfect stepping stone to figure out all the logistics of how we're going to live up here. And what's also really cool is that with Artemis, they're going to be sending the first woman to the moon. But not only that, they're also going to be sending the first person of color to the moon. But not only that, they're also going to be setting up lunar bases throughout the moon. So our technology has improved in the last 50 years, so we can do a lot more science and much more compactable, so we can do much more experiments up here while we're up on the moon. So maybe we want to set up a lunar base at the South Pole where the largest confirmed impact site is in the solar system. Maybe they want to go take a look at some collapsed lava tubes, let's say over here on the top left. Or maybe we want to go look at some new formed some mountain ranges that we haven't looked at before all the way on the right. But what's really amazing is that they're also going to have a space station that's going to be orbiting around the moon at all times called Lunar Gateway. So kind of like with the International Space Station that we just saw, something's going to be orbiting around the moon. And if anything was to go wrong while these astronauts were on the surface of the moon, they can launch off the surface and head to that space station where they would be safe. So again, we humans should be heading to the moon the next few years. Crossing my finger. Look out for any news about Artemis. And folks, when we look at the moon here on Earth, sometimes the moon feels incredibly close to us. It feels like sometimes you can reach out your arms and touch it. But the moon is incredibly far away from planet Earth. It's about 240,000 miles. Whew, 240,000 miles. Some of the adults in this room may have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon if you drove for 4 months nonstop, going about 80 miles per hour. Although I wouldn't recommend it, the roads out here are poorly maintained. Hee hee hee. And from here on out, folks, we're going to need to use a more useful measuring stick because at this scale, using miles is kind of like using inches to describe the distances between cities because space is just so large. So astronomers use a more convenient measurement known as light speed. And light travels at a mind boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so ever since, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But at last, folks, it's time for us to leave the moon behind. So everybody say bye bye, moon. We'll see you later. And now, folks, we're going to be stepping out into a larger realm of our solar system because now we're going to see the moon and the Earth as they slowly disappear. In fact, before we lose track of the moon and the Earth, I want to add some planet trails because you can easily lose stuff out here in space. And also, folks, on our journey today, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination thanks to computer models like OpenSpace, showing us the most accurate images and information available. And now you can see the nearest star to us comes into view, the sun. So here comes the sun. Do, 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 do. And to tell you folks, the sun is really, really far away from the Earth as well. The sun is roughly about 93 million miles away from the Earth. Whew, 93 million miles away. That is a good distance. But in terms of at the speed of light, that's not that far at all. In order for sunlight to travel that 93 million miles away between the sun and the Earth, it only takes sunlight about 8.5 minutes at the speed of light. So not that far. Now, this is a really cool concept to keep in mind because let's say the sun was to turn off all of a sudden, it was no longer emitting sunlight. That last bit of sunlight will travel that 93 million miles, travel that 8.5 minutes, and then all of a sudden the daytime will become nighttime here on planet Earth. Now, again, this is such a cool concept to keep in mind because this works for really far away objects as well. Let's say we're looking at a star out in the distance that's 70 light years away from us. Well, we're looking at that star as it looked like 70 years ago because that sunlight or that starlight that just reached us traveled 70 years to get to us. So when we look at really far away objects in space, it's kind of like looking back in time in a sense. Pretty cool. But now that we have a nice bird's eye perspective of our solar system, let's get a crash course or a refresher of what's inside of it because there's a lot of cool stuff in our solar system. Right in the middle, of course, is the biggest thing, our sun, the star, our star, the sun. And then the closest planet to the sun, we've got Mercury, then we have Venus, Earth, that's us, and then Mars. These are the rocky terrestrial planets. These are places where we can actually land a spacecraft on. And then past the orbit of Mars, we have this really cool thing called the main asteroid belt. And this is what it would look like if I highlight all the asteroids in our asteroid belt. There is quite a few of them, so give it a second. So that is our asteroid belt, folks. Whew, there is a bunch of asteroids in there, so just be careful. And then past the asteroid belt, we have the really big planets, the gas giants, the Jovians. We've got the biggest one of them all. We've got Jupiter. And then after Jupiter, we've got Saturn. And then we have our icy gas giants after that. We've got Uranus, the funny one. And of course, we got Neptune. And of course, we can always add everyone's favorite and lovable dwarf planet, Pluto. So there's the orbiter Pluto on the far right, right over there. And a lot of people don't realize that Pluto hangs out in this outer part of our solar system called the Kuiper Belt. And a lot of folks tend to ask, hey, Christian, what's the Kuiper Belt? I've never heard of that before. Well, folks, the Kuiper Belt's going to be all this stuff. So you can kind of think of the Kuiper Belt like a second asteroid belt way out past the orbit of Neptune. And where you're going to mostly find out here are icy asteroids and short period comets, comets that don't stray too far away from the sun. So they have a nice little short orbital path. But in 2006, we found more than 400 objects out here. So as we're constantly still scanning our solar system, we're still finding new stuff all the time. So we haven't figured out our entire solar system quite yet. So we're finding new things all the time, folks. But I want to put away the Kuiper Belt because that's just a whole lot to look at. And now, folks, I'm going to be adding on screen some of the many different spacecrafts that we sent out in the 1970s to explore our solar system. So now on screen, we're going to have the trajectories of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2. And the latest of them all, New Horizons, which did a quick flyby of Pluto in 2015. We can see that interaction as we swing around. It should be right over here, close to Pluto. So you can see that interaction. Thanks to that flyby, we are able to get some amazing high definition images of that dwarf world. And whew, Pluto just looks stunning. So highly recommend taking a look at those photos. And just to let you know, folks, all of these spacecrafts are traveling fast enough to escape the sun's gravity and leave our solar system behind. But even the most distant of these robot adventurers, Voyager 1, has not traveled as far as light travels in a single day. In order for sunlight to travel all the way out to the orbit of Pluto, it takes about 5 hours at the speed of light to get this far. So only 5 hours. That's not that far either. But folks, let's leave our planetary scale behind because now we're going to be heading out into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us about 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. And let me just make sure my calculations are correct. Sometimes Alpha Centauri sneaks up on me. All right, so Alpha Centauri is going to be this star system on the far left, right over here. So again, 4 years at the speed of light just to reach the next star system to us. But that doesn't really put into perspective of how long it would take us humans to travel that distance. Well, folks, if you're getting in a rocket ship today, left planet Earth, and head over to the next star system, it's going to take you about 8,500 years to cross that distance. Whew, and that's just a one-way trip. But, folks, let's stop and consider whether humanity has made its presence known beyond our solar system because now we're going to be stepping inside something called the radiosphere. Alrighty, folks. So, again, we are now inside the radiosphere, and this represents the current limits of the most distant radio signals humanity has ever broadcasted or rather leaked into space. And it extends about 90 light years in all directions, emitting out from the Earth. And this first began in the early 1930s with strong radio waves, early television, radar signal, and then later the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. And humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. And since all these signals are electromagnetic, they are traveling at the speed of light. So this is kind of like humanity's electromagnetic footprint in the universe. And of course, folks, the radiosphere is always expanding at the rate of 1 light year per year. So is anybody out there listening? And now, folks, I'm going to be adding on screen some many markers. These markers are going to represent so many thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth like with conditions suitable for life as we know it. So far today, we found 5,000 confirmed exoplanets. Planets besides are the ones in our solar system. And that 5,000 exoplanet number is going to be increasing as the years continue because we have space telescopes where their whole purpose is to find as many exoplanets as possible. So that 5,000 number is going to be going up. Now, to say if any of them are Earth like with conditions suitable for life as we know it, well, we can't answer that question quite yet. Pretty much new space telescopes are being developed right now, so it's going to be a few years before those are made and then launched into space. So it'll be a while before we can answer that question. But the more important point here is that quite a few of these planetary systems are within that 90 light year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. Now, to give you an example, let's say we live in a star system on the far side of our radiosphere. Let's say this one on the left. We find an alien civilization somewhere over here towards the middle. We shoot them a text message, takes 60 years to get to them. They listen in, answer back, another 60 years to get that message. That is a 120-year conversation in the making. Whew. And I can barely wait for a text message from my friend. But, folks, of course, planetary systems beyond the radiosphere, more than 90 light years away, have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. But I want to put away our exoplanet markers because there's a whole lot of them. But I'm going to leave our radiosphere up on screen. As huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way Galaxy. Alrighty, can anybody see their house from here? Just kidding, y'all. So again, we're now looking down at our Milky Way galaxy, and our Milky Way galaxy is incredibly large, folks. If you wanted to cross it from one side to the other, it's going to take you about 130,000 years at the speed of light to cross this distance. Enormous. But not only that, our Milky Way galaxy is so huge, we estimate that there's at least 300 billion stars in our galaxy alone. If our recent discovery of so many exoplanets just within our small neighborhood within this vast star city is any indication, there could be billions of planets and potentially millions of Earth like planets throughout our single galaxy. And before we leave the Milky Way galaxy, I do want to show you it from the sideways perspective. When you look up into the night sky, you probably heard a friend say, "Hey, look, you can see the Milky Way." Well, what they're referring to is the Milky Way plane. So that's what you're seeing up in the night sky. Now, this is important because we live in a flat spiral disk of the Milky Way. So when scientists and astronomers want to learn about the universe, it's so much more easier for them to point their telescopes galactically north and galactically south instead of looking through the plane of the Milky Way, which has planets, stars, gas, debris, things that block their view of the universe. So keep that in mind. That's going to come important in just a little bit. We like to point our telescopes galactically north and galactically south. But folks, the Milky Way galaxy is only one of many hundreds of billions of galaxies that comprise the known universe. So in this giant leap, we're now going to see a view where each point of view no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. And we live in a local galaxy group which contains about 30 galaxies, large and small. Also includes the nearest large spiral to us, the Andromeda Galaxy, only 2 million light years away, just next door and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And as we continue expanding out, folks, you're now going to realize that galaxies are not evenly distributed throughout space. Instead, galaxies like to clump together in large groups and clusters, or they like to avoid each other where there's very few galaxies or no galaxies at all, voids. So we can see a nice galaxy cluster right off to the left. We can see some galaxy clusters up towards the top right over here, a little bit more sparse. And then we can see very few galaxies or no galaxies at the very top right and at the very top of the screen as well. So you can kind of think of galaxies like people. They like to hang out together or they like to avoid each other. Hee hee hee. And folks, we've zoomed so far out now that the picture that we're looking at represents the closest 30,000 galaxies to us in space over 300 million light years across. We've got to give thanks to an amazing astronomy group of folks who worked at the University of Hawaii who compiled this amazing representation over decades of time. So big shout out to them. But now, folks, we have automated systems that are mapping even the most distant galaxies. So now we're about to see the very large scale structure of the universe. And remember, folks, every single point of light that you're seeing, that's not a star, that's an individual galaxy. Whew, I feel small. And just a heads up, folks, the large scale structure of the universe is not shaped like a bow tie or a butterfly. Remember when I just mentioned that we live in a flat spiral disk of the Milky Way galaxy? Well, if you're lining it up just like so, it's going to go right down the middle. So again, we like to point our telescopes galactically north and galactically south instead of looking through the plane of that Milky Way, which again blocks our view of the universe. But astronomers still want to make sure that there was galaxies through the plane, so they have this nice purple survey right in the middle. You'll notice that they were still able to find galaxies, just not as many and not as far. Pretty much, we have to wait for our technology to advance, and once that happens, we'll be able to fill in all these gaps that haven't been mapped out yet. So you can kind of think of all this stuff, but in every direction. But folks, it looks like we're also running close out of time on our tour of the universe. 30 minutes is just not enough time to talk about the universe, unfortunately. So let's continue pressing on. And now, folks, we're going to be encountering these objects, really distant objects known as the quasars. And the quasars are going to be represented by these nice orange dots at the very edge of the large scale structure of the universe. So we can see them off to the right and off to the left as well. Now, quasars are short for quasi-stellar radio sources, and these blazing objects are all billions of light years away. So now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenager version of the universe. And before there was a teenager, there was a baby. So let's press back to a time before quasars, planets, stars, and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. Alrighty, folks. So we're at the very edge of the observable universe, and what we're looking at is something called the cosmic microwave background image, or the CMB image for short. Now, all evidence indicates that the universe that we live in is about 13.8 billion years old, and this is data compiled by Planck and other radio telescopes. And the picture that we're looking at is a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And what we're looking at is not a typical photo either. Instead, what we're looking at is a temperature density image, where the light echoes of the Big Bang are color coded, with the lighter areas corresponding to the hottest, least dense regions, and the darker areas, the coolest, densest regions. These fluctuations in temperature and density are really, really small, extremely tiny. They vary no more than 1 part per 100,000, so very minute differences. But these small differences gave rise to the large scale structure of the universe, that clumping and clustering of galaxies that we saw moments ago. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But folks, we've traveled as far back as the law of physics can physically allow us to go, so we only have one direction left to go, and that's going to be back towards planet Earth. So let's find a nice entry point through all these quasars and galaxies. This looks like a good spot. And let us make our return trip back to planet Earth, folks. Alrighty, folks. So we're crossing an expanse of over 13 billion light years, and we present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. And we live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. With that thought, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But it looks like we're making our way back to our Milky Way Galaxy, folks. And we're heading straight for that radiosphere. And of course, we're making our way downtown, walking fast faces past them. We're homebound. Dun-dun-dun-dun-dun-dun. And now we're entering our solar system, our star system, passing those spacecrafts that we sent out in the 1970s to explore our solar system, passing the Kuiper Belt, and making our way to the third rock from the sun, our homeworld, the only place we humans have ever called home. All the people that we love and hold and cherish all live on this one planet. And it looks like we're passing the orbit of the moon, the furthest we've ever sent humans out into space. And folks, as we make our final approach back to planet Earth, this is going to be the end of our Tour of the Universe show. And I want to thank y'all for stopping by and watching with us this afternoon. But it looks like we made it back home to planet Earth safe and sound. And with that being said, that's the end of our show, folks. Thanks for stopping by.